Alright, so let's do a couple more examples. We'll do a few more basic ones, and then we'll turn it up a notch or two and see how any one of these other indeterminate forms can be tweaked. I'll show you the art of tweaking to get it into one of the Lhopital forms. Okay? Alright, so next, take this one. This is a classic example. This is I would call one of these, I'll call this one of the basic ones, and it goes like this. First thing you do is you would try the plug-in method, and the plug-in method would give you 0, cosine of 0 is 1, it would give you 0 in the numerator and 0 in the denominator. Perfect indeterminate form, perfect for Lhopital. Then you'd say, okay, here I'm going to do Lhopital. Lhopital says that you could say the same limit, but on the numerator you replace this with the derivative. The derivative, that would be sine of x, and on the bottom you look at that and you take the derivative of it, that would be 4. And now you give yourself another limit, hopefully an easier limit. This one seems to be very, very doable. Done. Just like that. Piece of cake, huh? Let's do another basic one. That was so fun. Let's try another super basic one. Whoa, I made this to the 4th, or doesn't matter. Let's do this one to the 4th. If I try the plug-in method, x is going towards infinity, I would get infinity over infinity. This is a perfect Lhopital format. Any one time you have infinity over infinity or plus or minus, then it's perfect Lhopital form. So I can go on and apply Lhopital and say this would be the same as the limit, so long as the limit exists and is finite. Bottom is not 0. I could apply Lhopital and say, well, okay, I'll do the derivative on the top, which would be e to the x, and I'll do a derivative on the bottom, which would be 4x to the 3rd. And I give myself another chance at the plug-in method, see if that's removed the discontinuity. I get infinity over infinity and say, whoa, that's another excellent opportunity for Lhopital. So I do it again, the limit as x goes towards infinity. On the numerator, that would be e to the x. On the denominator, of course, that would be 4 times 3 times x squared. And then I could try the plug-in method again, and the plug-in method would give me infinity over infinity. You say, whoa, this is a Lhopital party going on here. I could do Lhopital again, and I get the limit as x goes towards infinity, e to the x all over 4 times 3 times 2 times x, and that I give myself another chance at the plug-in method. Of course, I get infinity over infinity again, and I say, whoa, another excellent opportunity for Lhopital. This is Lhopital fest. And so I would do the limit as x, whoa, I need to write that line. The limit as x goes to infinity. The derivative on top is e to the x. The derivative on the bottom would be 4 times 3 times 2. And of course I give myself another chance at the plug-in method. Now I get infinity over 12, or whatever that is, 24. 4 times 3 times 2. And of course that's conclusive. The limit is infinity. And there you go. We did the limit. A little Lhopital fest going on here. Sometimes you have to do it over and over again. It's no problem. Don't be afraid. Alright, those are just some little baby examples. Let's try one more baby example. This one, of course, gives you, when you try the plug-in method, it gives you infinity over infinity. So you try Lhopital, and you're doing, I should always write the limit here. Sometimes I forget, but it's 5 times 3 times x squared. I'm looking at the derivative in the numerator, plus 3 times 2 times x, all over 2 times 3 times x squared, plus 2 times x. And then I try that limit again as using the plug-in method. Of course I get infinity over infinity again, so I try Lhopital again, and that would be I try Lhopital again, and that would be the limit as x approaches infinity. I should have had limit here, of 5 times 3 times 2 times x plus 3 times 2 all over 2 times 3 times 2 times x plus 2. And if I try the plug-in method again, I get infinity over infinity. Yeah, that's what I like, because then I can apply Lhopital again, which I will. And so then I get the limit as x goes towards infinity, 5 times 3 times 2 all over 2 times 3 times 2. And of course that's the limit, and because there's no more x's. And we're good. A little baby Lhopital example. Alright, this one's a little bit more than a baby example. This one's going to showcase the fact that any one of the famous indeterminate forms can be tweaked. We'll do this on the next example. Peace.